Exactly. You can only hope that the Venn diagram of people who understand token bindings and the Venn diagram of people who understand how to get here is sort of like non-zero intersection. All right. Can we get a volunteer to take notes? Or do we have to like unvolunteer people? That's always a possibility. Well, thank you, Mike. And can somebody sit on Jabber? Are you going to do that anyway, Jeff? All right. So if somebody turns up, you can channel them. I don't know that there are people absent though. But we'll see, I guess. All right. So the room is being re-architected. Oh yeah, it's the batteries. Excellent. It's always useful. All right. So
I wanted to close it to him because he's not good at walking.
Well, if I'm going to scribe, I'm going to be able to ask questions.
Okay.
that's a good point. You can fight about it later. All right. All right. Welcome. Should we start? Let's start. Oh yeah, let's do blue sheet. Let's do blue sheet. Where is it? Oh, you do it.
Yeah.
All right, you do that one. All right.
Is it live? Now it is.
All right. While we get the blue sheets going, while our beard fashion model in residence gets the blue sheet going, take a look at the note well. I have no idea whether this is the latest version, but you all know what it says, or you're supposed to anyway. All right, you want that? All right.
Pens? Yes, we do.
Yeah, we got pens. All right, so we got some stuff to do today. I think the first thing is to look at our agenda a little bit. We're going to just briefly look at a screenshot of data tracker to note the status of our core documents, and then it's our usual suspects of things plus one newcomer. So it's proxies, it's the various forms of 1 and 0 RTT. Nick isn't going to do slides for that. He's just going to do a quick update. And then we're going to have a little bit of feedback session from the informal WOT working group meeting on I think it was Monday, the Barboff. And hopefully that can turn into a discussion of how we get fetch moving a little bit. And then finally we have Mandiam here to talk to us a little bit about token mining attestation, an independent draft that I think he wants us to adopt at some point. And then if we have time, we have time. So let's look at the screenshot. So I think I grabbed this last night, so I think it's up to date. So this is it's on the next ISG telechat, all the core documents. So we are. I guess we're over one of the major hurdles, and that's good.
Yeah, there's no outstanding discusses or anything that we're anticipating is going to be controversial, but our authors are very confident, which doesn't make me quite so much.
Well, we'll just cross our fingers and hope for the best, I guess. That leaves us a draft TLS 1.3 thing and the proxy document, which Brian, I think I'll ask you to talk about right now. Let me just bring up your. How to make. To look at. There we are. All right.
So yeah, skipped ahead, but that's all right.
Oh, we can look at that first.
The title, HTTPS token binding with TLS terminating reverse proxies, shortened to TTRP. Thank you, Jeff, for saving some time on that. So just, I'm gonna do a little bit of review and set context here. I apologize for you that have seen some of this before, but the basic problem statement is that HTTP application deployments are very often set up where they have TLS terminated by some sort of reverse proxy sitting in front of the actual application in the network topology. And these terminators are sometimes products like, you know, your F5 or open source solutions, Nginx, Apache will do this sometimes, or increasingly now we're seeing services that do it. Amazon's application layer load balancer, Cloudflare, those kind of things all do this job on behalf of the application in front of the application. And for applications that are deployed in this kind of situation, something needs to happen. Some sort of information needs to be communicated from that TLS front end layer back to the application in order to actually take advantage of token binding. At least in the general case, we've seen a few sort of custom solutions that'll automatically bind cookies for you by rewriting them. But for the application to do things like deal with the referred token binding and bind in ways that the proxy can't necessarily anticipate, which is a lot of needs, something needs to be communicated from that front end to the back end. In the absence of some standardized way of doing this, different implementations will do it differently, or maybe not at all. So I'm trying to get ahead of that and provide some standardized guidance about how to make this work so that products, services, open source systems can interoperate easily. Next, please. So sort of an overview of what we have in the draft now on version 3. So we try to define a couple of HTTP headers, a few HTTP headers that enable this TTRP and the backend server to function sort of together as a single logical server-side deployment of HTTPS token binding. So from the client's perspective, it looks like a single server doing all the right stuff, but in the backend, there's information being communicated such that they can do different respective jobs to sort of form the whole of the processing. What happens is the reverse proxy validates the token binding message that was sent from the client in the sec token binding header, and it removes it from the dispatch request that it forwards onto the backend application. Assuming it's valid, it adds the sec provided token binding ID header that itself contains the base64 URL encoded provided token binding ID, and that's added to the dispatch request. If in fact there's a referred token binding, it does the same thing, encodes it and sends it as the sec referred token binding ID header. Added in this most recent draft then is this sec other token binding ID header, which can have additional token binding types and their IDs added to it and communicated to the backend. Something that has been asked for a couple times in the last few meetings that I've balked at a little bit, but have finally added into the draft, at least for the sake of discussion. In this case, there's some kind of trust is required between the TTRP and the backend server. They need to know who they are. They're deployed together. They're functioning as a single unit, and that needs to happen. They need to trust each other. And the TTRP is required to sanitize some of these headers. So that includes stripping the above mentioned headers if token binding hasn't been negotiated, if they're not appropriate, so that the client itself can inject these things through the proxy and onto the backend application and spoof it. Next slide, please. So just to give a visual view of this, I don't know, help me a little bit. You have your client here that's doing what I'm calling old-fashioned token binding over HTTPS. So old-fashioned, it's almost in the RFC editor's queue, so it's old. It does the normal negotiation with the reverse proxy and sends the sec token binding header. The reverse proxy does the negotiation. It also accepts this request, validates the token binding message, and sanitizes headers, assuming everything's okay. It dispatches the request, and although it looks kind of similar, you can see it's a little bit smaller, and it has the sec provided token binding ID header, and behind that it has just the encoded token binding ID. So it's validated the signature and stripped out sort of from the application standpoint, the extraneous stuff that it doesn't need, but it's passed along the token binding ID itself, which is the content that the origin server or the backend application itself will use to bind its cookies or tokens to, either to that directly or to maybe a hash of that. And then the origin server is able then to do the actual binding of the tokens based on this information about the validated token binding that's being passed from the front end. Next slide. So a few changes since Singapore. Published 2 new drafts with mostly pretty minor stuff. Updated the boilerplate to use 8174, which is what everyone's doing nowadays. So I did the same thing, added a few things to the acknowledgements, updated references. I think they're still up to date, but hopefully soon I'll be able to update those to actual RFCs. Few minor editorial things, reworded a few things to try to make it a little bit easier to read. Reformatted the document a little bit to try to make the header names, the newly defined header names, more prominent. As I was looking at it, they kind of got lost in there, so hopefully they stick out more. And define the encodings first so that you read the encoding, and then when you read about the headers, the actual header definitions, you can refer back to the encodings. And probably the most, well, definitely the most sort of functional change is I added a new header which allows for additional token binding types, those other than the provided and the referred, to be conveyed from the front end to the back end. And this is a newly named header. It's a comma separated list, so there can be more than one. It could happen, I guess. And each of those individual values is a concatenation of the base 16 or hex encoded token binding type, which is actually just a single byte. So that's why hex seemed like the most reasonable encoding there. A period character to distinguish the two pieces, and then the base 64 URL encoded token binding ID, which is the same, that piece is the same format as the other token binding ID encoded. And so if there are additional types, even though they're not defined, this draft now specifies a mechanism to convey them. So they're there now. Next slide, please. So next steps, looking on here, it's been relatively quiet and it's kind of a small room now, but I'm looking to get some level of consensus on this new header and the functionality it provides. To be honest, I sort of balked at adding it for a while because given that there are no other types defined, was concerned about the real world applicability of it, as well as bloating the draft and making it more complicated than it need to be. After adding it, it doesn't make it that much worse. It is extra text, it is extra functionality, but it's not that much more. So I'm maybe less opposed to it than I was, having written it down. But I guess I'm looking for consensus one way or the other on whether this is what we really want to have in there. And then pending some decision on that or lack thereof, I feel like we're getting close to taking this to working group last call.
Vinod Anupam, Google. I hate to revisit this because I'm pretty sure we did talk about it earlier, but in one of your earlier slides, you said that this architecture implies trust between the TTRP and the backend servers. Should we reconsider having some way of proving that the TTRP actually generated those headers at all?
No.
Because if we don't, then different systems are going to do it in different ways, and that's kind of something that we're trying to get away from.
Well, I mean, different systems may do it in different ways, but right now there are other systems where a reverse proxy sits in front of some other application and communicates information, relevant information about whatever's going on in the front to the back end through a header or various headers. And the standard or de facto standard way of protecting against a client injecting those headers is for the reverse proxy to sanitize the associated headers. So this is just going along with existing convention, although it's clearly documented and prescribed what needs to happen, what the actual header names are. So it makes it more difficult to misconfigure or deploy, but it's relying on existing standard practice, I guess.
And so the backend server pretty much has to know that it is receiving the headers from the TTRP. That's right. Somehow the way they do it right now. Somehow the way they do it, which might oftentimes I think will be based on the network topology that the backend server is only accessible from the reverse proxy, or possibly via some sort of authentication, some other form of authentication where the requests from the proxy to the backend are authenticated and thus can be trusted. Right. From a broader sense, that I have a real hesitation to try to define any sort of one-off mechanism around trying to protect or secure those headers that would be specific to this draft, where it's a broader issue of proxies and HTTP in general. And if there was some existing functionality that I could point to, I'd be happy to do that. But there isn't, and there's been some talk about it, but there doesn't seem to be a real appetite for developing anything like that.
Chris Newman, question I have about this is how it would so you mentioned SSL load balancers that do SSL and then you don't do SSL to the back end. My understanding is one of the protocols that's commonly used with them between the front and the back end is the proxy version 2 protocol, which forwards information about the client certificate and other stuff about the SSL connection from the front to the back end, in one of these deployments. What is your opinion on the interaction, where on the interactions where the proxy has to both, send data at this lower layer and then have data at the in the HTTP layer too?
So I'm not familiar with that protocol.
You're not. It's the one, I believe it's used in a lot of cloud service deployments.
What's the name?
It's called proxy protocol. And there's version 1, which is just forwarding the IP addresses of the proxy. And then version 2 is forwarding more information about the SSL negotiation. And the thing that's nice about it is it actually works with protocols other than HTTP, which will also have the problem of getting token binding information out of TLS.
They would, although they're not currently defined. So I honestly don't know. I think there would be a likely similar type of.
Do you have an RFC number for this or something?
It's not an RFC. It's a de facto.
Willie Taru.
Yeah, because for example, a place where we have, an early version of token binding on the standards track is the Scram SASL mechanism. And SASL is, authentication used by a bunch of protocols like mail protocols, LDAP, et cetera. And so making sure the token binding information from one of these front-end SSL things gets to non-HTTP protocols is interesting. And so I wonder if doing it at the HTTP level is the right level to pass this information.
So I'm very much trying to solve for the HTTP use case, as even indicated in the title itself. But that's the scope of this work and the target of this work. I don't know to what extent there might be overlap or applicability beyond it.
Kyle Nekritz. With the proxy protocol, you just get basically some information at the front of the connection. So you could use that to say, send the like the EKM, but you don't, like with HTTP, you're not gonna have the token binding message. So you're not gonna actually be able to send validated IDs like that.
That's a good point. Although presumably the message would be sent at some level. The proxy might not be in a position to validate. I don't know. I don't know how it would work, I guess.
So my understanding, I've actually not only familiar with the version 1 of this, but it just sends like a prefix on the connection.
It apparently doesn't send the headers on each request.
On the establishment of the connection?
Yes.
The initial part. Okay. So that would be completely, I guess it would be different. It would be a different bit of functionality that would need to be defined, or
like a V3, yes.
or an extension. I don't know.
An extension. Andrei Popov, Microsoft. I have a question specifically about other token binding ID. So my understanding is that this header is going to contain a list of token binding IDs that are not provided and not referred, right?
Yes.
Why did you choose to not combine then everything into one? Like why not carry provided and referred as well in that thing? Name it something somewhat differently, but
primarily a goal of simplicity to the backend application. So my sense is that the vast majority of applications will be using the provided token binding ID and will enable them to just pull it out of the header and use it directly. And some will use referred as well. And so having individual specific names for those headers that you can look at specifically for that was the goal, to make it simple on the backend application. Where this was in some views, maybe even unnecessary, maybe will never be used extension. So I tried to make the common cases simple.
Right. I was just thinking, if I were to design it, I would probably, if I'm willing to combine multiple token binding IDs into one extension, then I would probably combine all of them into that, because obviously it carries the type identifier of the token binding ID, right? Like
by necessity.
By necessity. So then I would probably combine all three, but it's just design aesthetics, I guess.
I mean, I guess to be honest, that's how you designed the message itself, was to convey them all together. And in my view, in HTTP applications, they're much more usable as individually sort of identified messages. So it's a lot easier at the application layer to deal with them like this. That's the reason.
Kyle Neckritz. One other thing I think might be useful to provide some guidance in this draft is on caching of different validated IDs. Because if you're doing, say, HTTP2 and getting a ton of different requests to the same origin with the same token binding, they're going to be the same for every request on the connection. And you probably do not want to spend the CPU to do the verification on every single one. But you may also want some more than just like a single cast value if you might get multiple token bindings on the same connection. So that's probably a consideration that a lot of people will run into implementing this, and it might be worth giving a little bit of guidance on.
So to be honest, I'm not exactly sure what guidance I would give there. And I think it's also generally applicable to token binding over HTTP in general. So I'm not sure this is the right place to try to provide that guidance.
So, who has read the latest version of the 03 version of the draft? Yeah, a few. Probably should be somebody in the back. Probably should have a few more reviews. So, I would like to get a couple of people who would stand up and volunteer to do like let's call it a pre-working group last call review, and just say, yeah, I've reviewed it, this looks okay. So if you can get some volunteers to do that on the list. Dennis, thanks. Perfect, William. And Nick, perfect. Thank you. Yeah, that I think that's fine. I mean, get a couple of reviews on the list. I mean, preferably sooner than later. And if there are issues right now, then bring them up. Otherwise, I think if the working group is okay, we can go take this to working group last call in a few weeks. Anybody have a problem with that kind of plan? All right. Or would like to suggest another plan? Yes, Tony.
Tony Nedlin. Just want to know how many people have implemented this.
There are a couple of implements. I know that there's an Apache, right?
There's a couple of early implementations and some.
Has there been any interoperability problems between them?
I'm not aware of any actual problems.
Or non-problems?
Yeah.
Okay.
It could be either. It's pretty straightforward, so there shouldn't be. But yeah, there's some implementation, some experience, but there's not a ton right now.
I mean, we did just before you, we had this sort of discussion early on in this work, and we all agree that yes, this doesn't have to describe what you do when you're an Akamai or Google, or it doesn't matter, right? You don't have interoperability issues with anything. This is for when F5 or HA proxy or Apache wants advice on what to do, right?
Yeah, if you're running your stack top to bottom, you can do whatever you want to make it work. The goal of this is to facilitate interoperability and mix and match between components in a stack. So.
Kyle Neckritz. Facebook's implemented this in our reverse proxies. We did it before I think this draft was really around, but we basically came up with the same thing. So I think it's a good approach.
Justin Richer, I haven't implemented this, but I wanted to provide the perspective that this is the kind of thing that if we don't standardize it, then will end up being a de facto standardization, like XSSL cert stuff, like that whatever Apache does, everybody else is going to copy and everyone's going to get it slightly wrong. And I've seen enough injection attacks against proxies that shadow stuff like this in the real world that it would be nice to have a document address this kind of thing up front before the rest of the world decides to just do it wrong anyway. So yeah, let's roll this out.
All right. So the plan is we got 2 stackies for a final review cycle, and then we do working group last call in within a month. Let's say within a month. All right.
Sorry, the late willingness, just echoing Justin's concerns there. I think we need it. I actually see a world where most application developers are actually using this with a reverse proxy rather than doing Tokbind themselves, especially since it's just so hard to get all the bits. You kind of just want to do it once at the reverse proxy level. So it makes a lot of sense and makes sense for cloud providers as well.
I do think that having something like this, if it's deployed, will help adoption and deployment overall, because it maybe moves some of the hard parts onto the piece of functionality that's more likely to be able to do it rather than requiring on individual applications. And maybe just to echo Justin's point, I've recently done some work with certificates, and some of the weird little, almost the same, but same concepts, but little inconsistencies, different ways people chose to do it is part of the motivation for trying to standardize something here. So we don't end up in that situation.
Vinod from Google. Just want to say that even for operators who have single stack end-to-end, if you're operating cloud-based services and you want your cloud applications to be able to use binding, you still need this kind of thing. So it's important.
Okay, thanks. You're not required to do this if you own everything. It's certainly a pattern that you can follow and you can do, but I feel like there was some misconception earlier on that this would be a mandate that everyone had to build their infrastructure this way. This is really just if you want to follow the pattern that exists, or you want to facilitate interoperability between components. Even cloud providers that are working with applications that can be deployed in their infrastructure might take advantage of it. But if you own everything top to bottom, it's not as important. Certainly you're not constrained by this or wouldn't be in trouble for lack of compliance. Not that you would be anyway, but.
All right.
For the notes, who were the 2 extra reviewers?
William and Nick. All right. I think we'll.
Thank you.
All right. Who's next?
I guess we'll do the attestations.
Actually, I think we were gonna do that last. I think. So we've gotten to
you want to do zero RTT?
Yeah.
I keep trying to forget zero RTT.
Yeah, Nick didn't want to do slides. He was lazy, so
Yeah, that's what it was. I was lazy and didn't do slides for this. So for draft Tokbind TLS 1.3, I'm going to give an update on 1RTT first. I've implemented it in Chrome and on Google servers, and those interop with each other. Facebook has also implemented it, and that interops with Chrome. So that's where we are for implementation. I think at this point it's ready for working group last call.
Right. So we're basically at the same place where we were just now with TDRP. So, it'd be great to have a couple of stackies to do a final sort of round of reviews before we launch into working group last call. So are we gonna have the same people, or maybe we can get some new people to review stuff? Let's start here. Who has read the last version of? Oh, a couple of guys. Tony, have you read it?
Yes. No.
I heard him volunteer.
Yeah. Have you tested with anybody else?
It's just been those 3 implementations that I know of. So Facebook, Google Client, Google Server.
Okay.
It's not nothing, right?
I'm just a little worried.
Were you to do an implementation, I'm
Yeah,
sure.
we have some other issues besides getting to the, with TLS. So I'm not sure it's been through enough yet to see if we're going to have any problems. It looks simple, but not sure if there's going to be any, interoperability problems yet or so.
Yeah, my experience with implementing it is that like if you have a TLS stack that does token binding and does TLS 1.3,
Yeah, those are the two combinations that you have to get right. So
yeah, so if you have those two separately, then your stack probably does the combination of them as specified in the draft.
Kyle Meckritz, I think it was very straightforward to implement. It's a very straightforward draft. I think it's ready. I'm happy to review it.
Okay, that's great. We can also ask for an early sector review. I mean, that's a possibility, especially since this is typically going to get assigned to them. I mean, this will get assigned to them anyway, right? And there are, people who understand TLS in the sector group. We could ask that. But, additional review from the working group is great. Are you volunteering?
I'm sorry, I lost context at one point. We're talking about just the basic token binding for negotiation for 1.3, right? Not the 0RTT?
Correct. We are not talking about 0RTT.
Okay. I missed it. So I have read the draft. I don't think I have the expertise to really have a lot of meaningful feedback from it. From what I do know, it seemed fine. So,
all right, but we got one volunteer from the Facebook guy, and we'll ask for an early sector review, I think, before we do working group last call. I think that's sort of all right.
That sounds good. And then my update on 0RTT token binding, that internet draft has expired. I haven't really had time to work on implementing it. So I think the best thing to do right now is sort of wait until there's more implementation interest and experience, and then pick that up again once there's more of that.
Once there's more 0RTT?
And people implementing it and trying to do token binding over it. Right now, I believe there are 0 implementations of that draft. And we've had lots of good discussions in this group about like the security concerns and how we want to approach that. But I just haven't had any work moving forward on that.
Right, and we decided to keep the documents separate at the last.
Yep.
Mike Jones is secretary. I thought you said at the beginning that 0RTT was implemented in Chrome.
No, I was saying that token binding for TLS 1.3 is implemented in Chrome. The slide has 0RTT listed before 1RTT, and I confusingly was talking about them in the other order.
Okay.
Yeah, it should have said TLS 1.3, 0RTT, and 1RTT. So everything Nick is working on, quick update, right? It was supposed to say that.
So is there a danger of people mistakenly using token binding with 0RTT in the near term without guidance that they're going to wind up having 0 security or some saying that token binding works with TLS 1.3 without giving people guidance about avoiding 0RTT or how to deal with it?
I believe in the 1RTT TLS 1.3 draft, there is a must not for doing token binding in 0RTT. So the 0RTT draft specifies a different TLS extension to use for doing that. The 1RTT draft says do not do this with 0RTT. So I think if anyone tries to do it over 0RTT, they will run into interoperability problems.
Right, because the keys, Andrei Popov, because also the keys are not the same, right? Like that you would export. So yeah, so I don't think there is a risk of that nature. Yeah.
Good.
Okay. All right. So we'll to summarize, we'll do for TLS 1.3, we'll ask for an early sector review and and we've got one stuck key, and then we'll do a working group last call if those things look like, if it looks like it's sort of okay. Sorry. All right. So who did we peg to talk about fetch? Vinod? Yeah.
So it looks like I missed the Monday meeting. Could you tell me a little bit about what happened on the Monday meeting, and that I can bring us up to speed on the fetch stuff?
There was endless discussion about character set mapping, how to parse URIs, and almost no discussion about token binding.
Okay, so yeah, the pull request for token binding in fetch has been alive for a while. It sort of has been going through stages where it goes into stasis and then gets revived and moves. But anyway, where we are right now, we've sorted out pretty much all the structural aspects of the PR. I think at this point, it's mostly editorial changes that need to be made. And another sticking point, so hopefully that should happen pretty quickly. Another aspect of it was, since the PR was started, a new policy that went into fetch was that we do web platform tests for the new features in fetch along with the PR. And the issue is that token binding isn't implemented in Python yet, which is what the infrastructure for web platform test server is. And so the conversation with the reviewer essentially was that we will create an alternate implementation for testing the token binding feature till token binding actually shows up in Python. And so the idea is once we have all of those things in place, we should be able to get everything moving. Okay.
How does that impact your intent to ship?
So our plan is to get the editorial changes in and see whether that is sufficient. Most likely that should be sufficient. And then we do the tests in parallel with everything else. In the worst case, we do the editorial changes and the tests, and then unblock the intent to ship. But I'm fairly sanguine that the former should be possible.
And I know one thing that confused me was fetch is kind of this weird creature of its own. So there's the fetch JavaScript API, which is only a small part of fetch, I discovered. So
fetch at a high level describes how a client should use HTTP to fetch resources in a browser. And so even though the fetch API is not used that much, the actual fetching of resources by a browser is all governed by the fetch spec at this point. So there's a very small change in the JavaScript API. Most of the changes that we're specifying are how the browser should actually use, how it should use token binding in the flows that it would normally use to get resources.
Okay. Any other questions?
Would it be possible to give a little bit broader explanation of what what you're really trying to do with fetch? I don't understand it very well. Or is it too? Is it defining like just browser behavior, or is it defining APIs that would be used that a application developer might use to work with token binding functionality, or both?
Well, so the fetch spec is primarily browser behavior. It's the implementation of, so what happens is, at an elemental level, you just make a connection and you send an HTTP request and you get a response. But what fetch does is it unifies everything, how cookies should work, how credentials should work, how cores should work into one unified framework, so that every part of the browser is using the same framework to fetch resources and honoring all the different rules that are being set up by the different aspects that get turned on and off. And token binding has one place in that big infrastructure. But it is very specifically I guess technically any client that implements an endpoint for HTTP and follows all the rules, which typically would be browsers at this point. So it's, I would say it's kind of an impedance it's a layer that matches up the IETF specs with what we want to see inside the browser. That's basically what I would characterize it as. Jeff,
yeah. Mike?
Hi, Jeff Hodges. So maybe this is helpful, maybe not. So the fetch spec basically defines the algorithms that they go off and implement inside the browser. It specifies browser gets. You can almost compile the spec into a browser.
Now, one more thing, the fetch spec does have a JavaScript API. So from JavaScript inside the browser, you can say fetch a URL, and that invokes the same underlying fetch mechanism. And so there's one brief change that we are adding into that API that would allow the possibility of the requesting context to trigger referred token binding type flows. And that's pretty much the only change in the JavaScript API. Everything else is a change inside the underlying browser implementation itself.
Okay, thank you.
All right. So again, this is not strictly speaking in the IETF remit, but you know, it's good to keep everybody informed. And there are, I mean, the standard, the deployability of the standard, if I understand it correctly, is really impacted by our ability to actually get these changes through. And otherwise, this is not, you know, it will severely impact our ability to actually get stuff running. All right. With that, I think we're at it's your turn. You dig out your slides. Hang on. Just gotta,
I hope you have it.
where the hell did my mouse pointer go? Yeah, there it is. So hid somewhere. There we are.
So thank you to the chairs for allowing me to present. My name is Gary Mundy. My affiliation is Qualcomm, but I know we're in the IETF now, so I'm going to talk as an individual. And this presentation is on attested TLS token binding. I'll admit I haven't been as deeply involved in this group as probably most everybody in this room. So if I make some generalizations or that may be misleading or inaccurate, please feel free to correct me, because this is mainly based on my understanding of specification through my participation in the W3C, and in FIDO, Fast Identity Online, FIDO Alliance. So, and this first two slides will be old hat for anybody who's been involved in the specification as to the motivation for token binding. But basically, it was addressing a problem that arises in federation systems where bearer tokens are issued to clients, and the bearer tokens themselves are vulnerable either to physical attack due to extraction and based on extraction at the device side, or possibly even when encrypted connections such as TLS are still subject to man-in-the-middle attacks. And when the attacker extracts the token, as we know, game is over. That enables a lot of other attacks too. And that was at least one of the primary motivations, my understanding, for kicking off the token binding work a couple of years ago. We can go to the next slide. So token binding, one of the key strengths of it is that the bearer must provide the proof of possession of the private key. when I say on every TLS connection to the server, I just realized that I'm reading that's actually inaccurate. You're not going to want to do a signing operation on every single TLS session, but I mean, it does it enough so as to validate the TLS connection to the server. The current specification actually does this by sending the token binding message based on signing the EKM along with the token binding type and Tokbind key parameters. Now, this is where I guess, I'm coming from a semiconductor perspective, but as far as we can tell, those private keys, make us, and how and where those private keys are stored make us scratch our heads a little bit. If user agents, for instance, the browsers are maintaining their own store of private keys, that's generally in user space, and there are vulnerabilities on that. Once again, an attacker could extract the private key and they could impersonate the client. Now, you might say, well, that's a physical attack. That's not easy to carry off. But, during the past couple of months while we've been, while the semiconductor industry has been trying to answer certain attacks that you may have heard of, such as Spectre and Meltdown, we've been having we've actually seen attacks verified where even for sandbox applications, they're able to get into other applications' memory space. It's not just a browser issue. Native applications that implement their own TLS stacks may still be vulnerable. Many of them use open source libraries such as OpenSSL, and there's not necessarily binding to any kind of secure environment of the private key store. So, I'm not saying these attacks are super easy to carry off, but they can, but they are feasible. Here we go to the next slide, please. So I'll give a little bit of definitions before I go into the motivation for this. So basically, I'm defining a signing process as any application or platform functionality that executes crypto operations such as signing. So when I say hardware-bound or hardware-secured signing process, that means the process will run in the context of a root of trust. Now, I'm hoping that we all have common definitions of what a root of trust is, but these are basically I would define it, I'm going from memory here, as something that's purpose-specific and generally isolated. So many hardware-bound signing processes protect private keys in trusted environments. So you may be familiar with trusted execution environments, secure elements, TPMs, particularly prominent in the PC world. Examples also include hardware secured authenticators, several of which we rolled out and certified in the FIDO Alliance. Such as authenticators running a trusted execution environment. We've actually, in the Android O version, we've actually, Android Key Store is now Trust Zone backed, when Trust Zone is the prominent trusted execution environment in the ARM ecosystem. So we're seeing this this protection of private keys becoming more and more efficient, more and more important, particularly in the mobile space. So relying parties can make, if they know how the key is protected, they can make decisions whether to continue a TLS session with the client in question or not. Now, how do they know what the protection of the private keys are? Let's go on. Can we move to the next slide? That's done by the process of remote attestation, which is a process by which software executing on a device provides an assertion that a relying party can use to verify integrity of the platform. And in this case, the attestation would be applicable to the storage of the private key. Attestations can also include a lot of other measurements too. Sometimes like health assessments of the platform. What do I mean by that? I mentioned that the browser is probably running in user space. We actually have commercialized attestation solutions that are trust zone bound from Qualcomm. Under they call it the Haven attestation solution, where we actually do measure the integrity of the operating system kernel, usually Linux. And we can actually provide that as part of an attestation. We also can record. It's also possible to record suspicious events such as protected memory access, which I mentioned as part of the recent attacks on ARM-based devices. And the attestation data is formed by combining these into a compact data structure that can be sent to a relying party. It's usually pretty important that that the attestation data be cryptographically verifiable, signed and/or encrypted. I think in the TLS context, the encryption becomes less critical if you're thinking of it, if we're looking at it primarily for privacy purposes. This is probably a lot of old hat for several people in this room, so I'll get to the proposal now. Okay, do we move on?
Oh, next.
Thank you. So what does this mean as far as the standard is concerned to to enable remote attestation for the private key? While it's already been hinted at the latest version of the Tokbind protocol, in fact, it's been in the spec for several versions now, there's a feature called the Tokbind message extension, and one of the uses of the extensions that's been proposed in that document is for an attestation. I think I first submitted this document 2 years ago to the working group. I don't know if that actually came about as a result of that, or maybe this is already in the spec. I don't remember. I have to go through the version history.
Well, I mean, you did submit it, but I can't remember whether it got a lot of review at the time.
Yeah.
But, no.
Yeah, and that's on me. I didn't attend the meeting. So this is what this idea is about. It's basically proposing what could be the first official extension for the Tokbind spec, and that is the relevant attestation data for this extension. Simple pair of an identifier and a B string to actually encompass the attestation data. Even though the current version of the spec actually seeds it with TPM, reference to TPM attestations, particularly, I don't believe in the spec. I referenced the version 1.2. I have to go back and check on that, but that would be for TPM. We've also defined many attestation types in the web authentication API. At the time I submitted this spec, the only one I felt it stabilized was a packed attestation, but now we have, now I think we progressed quite a bit where all of the formats are stabilized. I know several people in this room also participate in the W3C standards effort for web authentication. I'll mention that with a caveat. Yes, we may have to give a little guidance on the use of that in the context of a Tokbind attestation, because a lot of that is relevant to an authenticator attestation, but the formats are still fairly general purpose. Okay, I think we go to the last slide. So my recommendations is that the Tokbind working group can adopt this draft. It could even be information. It's currently listed as standards track, but I don't know how we would be treating extensions. I'm also looking for co-editors. I think that would be perfectly welcome. And also determine what would be the initial attestation formats for Tokbind. I know this is a huge interoperability burden to support everything under the sun. That's why I stayed a little conservative in the initial draft.
Right. I think I suspect this is not going to be able to be an informational draft. I think it has interoperability considerations, and that means it's standards track or experimental, but I don't think it's informational.
Okay. Yes.
Andrei Popov, Microsoft. So I think attestation is very important, and we're planning to support some form of token binding key attestation in Windows going forward. I was speaking of specifically about this draft. I think also the approach is plausible. I didn't read the very latest version of the draft, but I read the previous versions, and they lacked information about how specifically what goes into the attestation blob, how it's generated, how do you validate that attestation, and to me that's the key information. Like, not where you carry this in the protocol, that's important, right? But that's the simple part. The tricky part is how do you generate that attestation statement, how, if it's generated, if like one software vendor's application generated that attestation, how does another software vendor validate it? How do we deal with privacy, all of that stuff? And that's not in the draft. Therefore, I think the draft is not a good, in its current shape, it doesn't have enough information, basically.
I agree. I think we've gone through this actually with the WebAuthn spec. I know specifically when I was trying to compare the TPM attestation definition there and the verification procedures versus what my company does for firmware TPM. I had a lot of things, a lot of questions on it. I think I would probably take a similar approach there where I say, yes, we can refer to an underlying standard, but we would actually tell a verifier, this is the fields that you need to check. These are the fields that you need to, and based on exclusion, these are the rest of the fields you can probably ignore. But I agree with that. And certainly, I think what I wanted to know is what should be, as I mentioned before, since this is an interoperability point, what should be the minimum number of formats to be supported in the spec, and then I would actually work out the verification procedures. Because right now I'm just looking at it and I say, okay, in the WebAuthn spec, I believe we have 7 defined there, and I don't know how we're going to deal with interop there. So we certainly don't want to export such problems to this grid.
Andrei Popov, I just think if we had one defined method at least, to start, I think that would go a long way towards, understanding how, like, whether this is a good starting point, basically, that the working group can adopt.
Right.
It's just my point of view.
So it might be useful to understand what attestation format Microsoft was considering, whether it was Android attestation format or PACT attestation. One would tend to guess that it would be one that might align with web authentication, hopefully.
Tony Nadlin, at least the TPM attestation, since that's our main usage now with our Surface devices and stuff.
I can certainly augment the spec for TPM.
Right, but we do have software authenticators that will require PACT attestations also, so.
Okay, good. Those are the 2 that I seeded the spec with, so fantastic. Okay.
So what I hear here is a sort of a cautious interest from the working group in the topic, but sort of there doesn't seem to be clarity as to whether this particular approach is solid enough, right? Now, I think that's something that could evolve over time, right? If but it also needs a little bit of, it actually needs people willing to go and work on it, right? So I think John's question here to, for instance, to Microsoft is sort of apparently about the releases, right? Are you, or, at some point, right? Would you guys be willing to work on this, right? Or this version, or publish your own draft? I mean, there are many ways we can take this forward, right? A separate informational draft from Microsoft saying, here's what we do, right? Could be a discussion starting point too.
So Tony Nadlin, we do have some things in common, so I'm not sure we'd want to put together a separate draft, but we would work with Gary to fill in the gaps that exist in his draft today. I don't want to start another.
That's fine. I mean, I think that'd be even better if you guys could, huddle and come up with something, a common approach, and preferably stick a few IANA registries in there too to make everybody happy, right? That I think that would be.
Fantastic. Yeah. So I can, Tony, I guess I can work with you offline, and maybe if you want to identify a co-editor.
So it would also be nice if Google could at least comment on what attestation format they might be interested in. Because it's probably not TPM.
Vinod, I'll look into it and figure out what we can do. I agree, it's an important area. We probably should be working on it.
All right. In that case, I think the right approach from the working group here is to see what you guys come back with, an updated individual draft with sort of a few more editors on it that sort of seems to have broad support in the working group. I can definitely see that being in scope for our charter and be adopted, but it really requires that, because otherwise we don't actually see that people are interested in the result. Even though people are interested in the topic, that's not necessarily enough, right? But I think there's a plan. You go off, come back in Montreal with like a version 04 with like more names on it and more support, I think we're definitely we could definitely talk about the working group adoption at that time.
All right. Thank you very much. I appreciate the time.
All right. Yeah, that's it. I mean, we have open mic. So if somebody wants a mic to open, have we forgotten anything in the working group? As you can see, there's a little bit of work to be done, but you could sort of see the end of the tunnel. That's good. If nobody has anything to raise, then we give you
the time back unless somebody wants to sing a song or
do a dance or yeah. Nobody?
That's Fernand.
I mean, all right. In that case, you get a half an hour back. Thank you very much, and probably see you in Montreal. Bye.
Yeah.
What does Utica want to do?